Hi, hello everyone, and welcome back to my YouTube channel Spotify Learn. Today, let's discuss about second PUC MCQ have been discussed yesterday. Today, let's discuss the 3 mark questions based on the blueprint we will discuss. First is we will analyze the question, then write the answer. I have written also when it is repeated and all the questions. First, let's see the first answer. Let's see what the question they have given. They have given that is a set is from 1 to 14 and the relation is xy 3x minus y is equal to 0. We have to show that it is reflexive, symmetric and transitive. Okay, now to show that it is reflexive, first we will show it as reflexive. Okay, to show this, first we will take the set we will consider. Okay, 3x minus y is equal to 0 means we can take the multiples of 3. If you put x is equal to 1, it will be 3, and the same way if you put 2, it will be 6. The same way if you put 3, it will be 9. If you put 4, it will be 12. Because next it will be 16, that will 16, that is next it will be 16 is not in this set. Okay, so that is how we do. Okay, now if you take 16 and 15, next is greater than 14 is not allowed, so it is not belonging to R, so that is why we are not considering. This is the set which they have given. Okay, we have to consider this set. Now to show that reflexive, first let's see reflexive is what. Reflexive means 1 comma 1 should belong to R, but here it is not belonging to R, so therefore R is not reflexive. R is what? Not reflexive. So you can show one example and you can disprove, or you can show one example and you can prove. If one example is there to disprove also, it will be not reflexive only. Now let's see for symmetric. To see for symmetric, symmetric means what? A comma B, if you consider, it belongs to R, that is relation R means A, B comma A should also belong to R. That is the logic behind this. That means here A is less than or equal to B, here is B is less than or equal to A. Okay, so that is why they both are not equal, right? They both are not equal. Here see, there is A less than or equal to B, and there is B that is less than or equal to A also. So A less than or equal to B is not equal to B less than or equal to A. So you can say that it is not symmetric. For reflexive, you can consider for transitive. Okay, for transitive, you can consider 1, 3, 3, 9. What is the transitive? 1 and 9. That means AB belongs to R means BC belongs to R. These both should be AC should be belonging to R. See here AC, that is 1 and 9. 1 comma 9 is not belonging to R. So therefore you can say that it is not transitive. You can show all the 3 steps. It is not symmetric, not transitive, not symmetric. Okay, reflexive. Now next question they have given is y is equal to x plus 5. Y is equal to x plus 5, and next they have given x condition is it is less than 4. Okay, to show the relation will be what, you can substitute any value for x that is less than 4 and you will get the y value. Okay, first substitute 1. Okay, 1 2 3 you can substitute 1. If you substitute 1 plus 5 will give you 6, 2 comma 7 and 3 comma 8. This will be the relation for the particular condition they have given. Now to see for the reflexive, okay, now you can take 1 comma 1. Okay, that is only not belonging to R, therefore it's not reflexive. Okay, now for symmetric you consider, for symmetric you can take, if you take 1 6, 1 is not belonging to the relation, so therefore you say it is not symmetric also. Okay, now for transitive, you can, for this particular question, for the transitivity. Okay, now we should see for the transitivity. Okay, now you can take 1 6, that means 6 is not starting in any of the set. You can take 2 7, 2 7 is also not starting in any set, because you want a b and b c, right, to show ac. And even if you take the next, that is 3 comma 8, 8 is also not starting. This condition you will say that as, okay, now let me delete that. Now you can say this condition as variously. Okay, this you call it as this, so you can say that it is transitive. Okay, this particular is not reflexive, not symmetric, but transitivity is there with the condition of variously. Okay, you say that if you say 2 7, 3 8 and 1 6, these three numbers are also not belonging to this set, so you can say this is as variously condition, and you can prove that it is symmetric. Okay, sorry, transitive. Now next question they have given 1 to 5, right, 1 to 5, 1 to 5, and the that is y divisible by x is what they have given. Okay, y is divisible by x. To show for reflexive, you can take x comma x, you can take any number and that will be belonging to R for all x belongs to A, that is the set A. That means you can take 1 1 2 2 3 3 4 4 5 5, all are belonging to A. That means you can say that it is reflexive. Reflexive is done. For symmetric, for symmetric, if you take, the condition is xy and yx, right, that is 2 4. If you take example, I am saying 4 is divisible by 2, you can take here it is belonging to R, as 4 is divisible by 2. If you take 2, if you take this reciprocal, that is 4 2, it is also not belonging to R, that is why, because 2 is, see, 4 is divisible by 2. Okay, that is 2. You can not take here 2 and here 4, it will be divisible by, you will get some decimal value. That is why you are saying it is not belonging, as 2 is not divisible by 4. Okay, this is how you show that it is symmetric, not symmetric. Let's see the condition of transitive. I hope you know the transitive condition. For the transitive condition, let's take any y that is divisible by z, okay, and z that is divisible by some x component or any component. Y is divisible by x, y is divisible by x, so you can say that it is transitive. Okay, now you can say here it is reflexive, symmetric, but it is not symmetric, it is reflexive and transitive. For the next fourth question, they have given a plus 1. This is also the same condition. You can say that if you take b is equal to a plus 1, they have given, if you take any of the example, a comma a will be belonging to R, that is the required condition. But here, as b is equal to a plus a, b is not equal to a, right? If b, if you take a 1, it will be added, so that is why you will say R is not reflexive. For that symmetric condition, it is AB and BA, as you know. This is if you take the condition as, for symmetric, if you take the condition as BA, that is AB and BA, that will be belonging to R, this will also be belonging to R. A is what? B plus 1. Okay, A is what? B plus 1, which is false. B is equal to a plus 1 means B, A should be what? B plus 1. This is not given here. The set they have given is only a plus 1. This is true. This is false. So you can say this is not symmetric. I hope you are understanding. If you have any doubts, you can let me know in the comment box. If you are watching the video without subscribing, please make sure to subscribe and then watch the video. Next is for transitive. If you take a comma b, that will be belonging to R. That means B is equal to A plus 1, right? And next is for transitive A comma C, if you consider, that means C is equal to A plus 1. That is false. It's not there. So you can say that it is not transitive. It is not reflexive. It is not symmetric. It's not transitive. Final answer is this. Now for the next fifth question, they have given function of A is equal to function of B, right? Function of A is equal to function of B. They have given, and whether it is equivalence or not, we have to show. That means for reflexive, consider reflexive for all A belongs to X, right? X is the function they have given here. A belongs to X, okay? Now if you take A, f of A is equal to f of A. That means if you take to consider, here also if you consider A, that means A comma A will be belonging to R, right? So you can say that it is reflexive. Next for the symmetric, let's consider symmetric. For symmetric, you can take AB belong to R and BA. That means if you take the f of B is equal to f of A, also that will also be equal. If you take f of A is equal to f of B, that will also be true. So you can say that it is symmetric. Let's see for transitive. For transitive, it is A, B, B, C. If you take f of A is equal to f of B, f of B is equal to f of C. F of A is equal to f of B, and the same f of B is equal to f of C. That means A is equal to C. F of A will be also equal to f of C. That means it is transitive. Here all the three conditions is R is reflexive, R is transitive also. R is transitive also. I hope you got this. Next question is x minus y is an integer. X minus y is an integer they have given. For to prove for reflexive, that means what, you have to take same element that will be equal to 0. That will also be belonging to z. Z means what? Integer. So you can say that it is reflexive. Okay. Next for symmetric, let's take x y only you take, that will be belonging to R. That means what? X minus y belong to z. See the condition which they have given, you have to take. Okay. Now for next is y minus x, right? For y, that is y minus x will be what? Equal to minus x minus y, right? If you take out common here, it will be plus y and minus x. Plus y and minus x. This is how you write this. This will also be belonging to z. That means integer includes all the negative and positive value. So you can say that it is symmetric. Next, to prove for transitive, you take transitive x minus y and you take y minus z. Okay. If you take x minus y and y minus z, x minus z will also be belonging to z. So you can say it is transitive, and therefore it is R is equivalence relation. This is how you have to write. Okay. Now next question they have given. This is also the same way. You have given set A and x and works at the same place. Okay. That means if they work at the same place, you can solve this for reflexive, for symmetric, and for transitive also you can say. Now next question, they have given the condition is A is less than or equal to B. Okay. Now to prove for reflexive, A is less than or equal to A, that will be belonging to R. So you can say that it is reflexive. For symmetric, if you take, you can say if A is less than or equal to B, then B is less than or equal to A will be false, right? If you take some example, see 2 is less than or equal to 3, this is true, but 3 is less than or equal to 2. If you do this reciprocal, it will be false. So you can say that it is not symmetric. For transitive also you can take example, you can take A is less than or equal to B, B is less than or equal to C, that means A is less than or equal to C will be true. You can say it as transitive. Okay, so now you can consider here only example. 2 is less than or equal to 3, 3 is less than or equal to 4, 2 is less than or equal to 4, that is correct. You can show like this. You have to explain. Okay, I am showing in the steps, you can explain this easily. If you get this, you can explain. That is not symmetric, that is both reflexive and transitive. Next, the same way you have to do for a is less than or equal to b square. Okay. For b square, you consider a is less than or equal to a square for reflexive. If you consider for all a, okay, for all a, take, let's consider some example that is random 1 by 2. Okay, to disprove 1 by 2 is less than or equal to 1 by 2 whole square. If you take, that will be equal to 1 by 4. 1 by 2 is not equal to 1 by 4. It is not equal. So therefore you can say it is not reflexive. Next is you should show for symmetric. Okay, for symmetric the same way. A is less than or equal to b square means b will not be less than or equal to, this will be false. So that it is not symmetric. For transitive, you can take a is less than or equal to b square and b is less than or equal to c square. A is less than or equal to c square will not be true, that is false. So you can say that it is not transitive. For the next question, you can see they have given for a cube. Okay, the same way you have to see a is less than or equal to a square. We saw a, we saw. Now the question they have given is for a cube. Okay, now to show the same for the a cube, you have to consider the first condition is what? Reflexive. See, a comma a will be belonging to R means, that means a should be less than or equal to a cube. Sorry. Okay, now which is not there in the, which is not true. Why? Because if you consider 1 by 2 1 by 2 as a, that means it implies 1 by 2 is less than or equal to 1 by 2 whole cube. It is not true, because 1 by 2 is less than or equal to 1 by 8. Okay, that it is not true. So you can say that it is not reflexive. It is not reflexive. Next is for, you consider the condition for symmetric. Symmetric, I'll write it here in the right side. For a b belongs to R, right? b a also belonging to R. Here it is what the condition, a is less than or equal to b cube. Here it is what, b is less than or equal to a cube. That means if you take this both the condition, a is less than or equal to means you have already said that it is less than. Now b cannot be less than or equal to a cube. So you can say that it is, R is not symmetric. Now you take a is equal to 1, b is equal to 2 and substitute the value. 1 is less than or equal to 2 cube and 2 is less than or equal to 1 cube is not happening. So you will say that it is not what's symmetric. For transitive also condition is false only, because you can take a is b, a is less than or equal to b cube, b is less than or equal to some c cube. Okay, a will not be equal to c cube, so this will not be true. So you can say that it is not transitive also. Next is one of the important question. See this, what I have written here xy is in the place of a and b, just they have changed as x and y. Here they have changed as x minus y in the 2022 paper. Okay, now you can see first let's solve for reflexive. 2 divides 2 divides a minus b, what they have given, right? Now for a minus a, if you take, will be equal to 0. 2 divided by 0, that means it will be belonging to R, that is z. So you can say that R is reflexive. For symmetric condition, 2 divides a minus b, then 2 divides b minus a will also be belonging to R. This also belongs to R, that also belongs to R. That means you can say that it is symmetric. You can see the condition for transitive also. For transitive, 2 divides a minus b and you can say again 2 divides what, b minus c. You have to consider the same element, and 2 divides a minus c will also be belonging to R. So you can say that it is transitive. It is equivalence. You, if all the three is agreed, you can say that it is equivalence. Now the 12th question which they have given is a minus b is divisible by 2. Same question, they have just changed the, there it was 2 divides a minus b, right? Here what they have done, just a minus b divides 2. That means it is reflexive, symmetric and transitive. The same way you can solve this question. Okay. Now for the next question what they have given, this is one of the most important question. Okay. Understand it carefully. Mod a minus b is what they have given condition even, and they have given 1 to 5. Okay. For that you take for reflexive, that is for reflexive you can take mod a minus a, that is a mod a minus a will be equal to what, 0. That is what, even, that is true. So therefore you will say that it is reflexive. For symmetric you take, okay, for symmetric what you will take, a minus b. If you take this, if a minus b, then even b minus a will also be even only, right? It is also what, even only. So you can say r is symmetric. Next is third, for transitive. For transitive, a minus b, b minus c, that means a minus c will also be equal to what, that will be belonging to r. That means it is even, it is transitive, it is equivalence relation. Equivalence relation. 14th question, they have given PQ. PQ is what, OP is equal to OQ, that is origin R, right? For reflexive you can take, for reflexive condition you can take it as OP for any point P, like they have given any point set of points, right? Right. Okay, so now you can take OP is equal to what, OP only. That will be what, true, it is reflexive. Next is symmetric, you consider symmetric. If you take OP is equal to OQ, that means OQ will be equal to OP also. That is also true. Next is transitive, you take for transitive OP is equal to OQ. That means OQ will be equal to some OR or random variable. That means OP will be equal to OR. That is also true. So you can say that it is equivalence relation. This is repeated in 2016 paper. That is they have given the condition is x is less than or equal to 12 but greater than or equal to, how you have to read this is, see this condition, x is less than or equal to 12, okay, and it is greater than or equal to 0. This is the condition which they have given. So for reflexive condition you can take a minus a, okay, here also it is multiple of 4. A minus a will be what, equal to 0. It is what, multiple of 4. That means 0. 0 is divisible by all, right? So you can take it as reflexive. Reflexive condition is agreed. Next for symmetric, let's understand. A minus b is equal to some, assume that it is some 4k, that variable. That means b minus a will be also what, 4k. B comma a will also be belong to R when a comma b belongs to R. So you can say it is what, symmetric. Let's check for the condition. Transitive, for transitive also you consider a minus b is equal to some 4k variable. That means multiple of 4, right? Here it can be 0, 1, 2, 3 or anything. Now b minus c also will also be equal to 4k. That means a minus c will also be what, equal to 4k. That means transitive is also agreed. It is what, equivalence relation. Next question is also same. They have given just a is equal to b. Same for reflexive you can take a is equal to a, and for symmetric also you can take a is equal to b means b is equal to a is equal to b is equal to some c means a will be equal to what, some c. So you can show that it is equivalence relation. The same way. And the next question is about the congruency. Okay, I hope you know the concepts of congruency, the basic concept, it is enough. See, for when you have reflexive, See, when every triangle, they have given the triangle, right? Every triangle is congruent to itself, so you can say that it is reflexive. For second, symmetric, that means T1, if you consider some triangle T1 that is congruent to T2, then T2 will also be congruent to T1. This is the symbol we use for congruency. That means it is symmetric too. Symmetric also. Now for the third condition, they have given T1 is congruent to T2, some T2 is congruent to some random triangle 3, T3 means T1 will also be congruent to what? T3. So you can say that it is transitive also. Now next question is repeated in 2024. Listen it carefully. They have given perpendicular. L1 is perpendicular to L2. Okay. Now for, see, no, for let's consider reflexive, understand it carefully. They have given set of line in a plane, that means L1 and L2 is the line. L1 is perpendicular to L2. You have to prove it is symmetric, but neither reflexive nor transitive. Okay, it is reflexive means no line is perpendicular to itself. It is congruent, triangle are congruent, but it is not perpendicular. Line are not perpendicular to itself. So you can say that L comma L is not in belonging to R. That means if you say L1 and L2 means reflexive condition is A comma A, right? If you take that, it is not belonging to R. Next, if you take the condition of symmetric, symmetric L1 L2 L2 L1, that is happening, that means it is perpendicular. If you take some two lines, that is not parallel line, it is perpendicular. If you take some two lines like this, it is perpendicular. L1 is perpendicular to L2, that means it is happening, and L2 is also what? Perpendicular to L1. This is happening in this condition, so you can take it as symmetric. The same way, if you consider the condition for transitive, transitive also what? L1 is perpendicular to L2 means L2 will not be perpendicular to L1, L3. Okay, that means L1 is not perpendicular to L3. It is not transitive. The same way you can solve this also. Some parallel lines you draw and understand, and you can draw this. Find the set of lines they have given, right? For the next question, I'll be solving that. See, it is transitive, it is equivalence relation. Next, what they have given is y is equal to 2x plus 4. It will be equivalence relation. Y is equal to 2x plus 4 means all lines with slope 2 is the meaning. Okay, that means y is equal to what? 2x plus c. That means c will be belonging to R. This is what they have given condition. Next is they have the same number of sides. This is also same. You will get reflexive, symmetric and transitive because they have the same number of sides. Next is about the equivalence relation on set R1, R1 union R2. R1 union R2, that cannot be equivalence relation. Why? Because R, it is not equivalence. Why? Because reason is that if you take R1 union R2 is reflexive and it is symmetric also. If you take R2 union R1 or R1 R1, this is for symmetric, this is for reflexive. It may not be, it is transitive, it is not happening. They both are true for reflexive and symmetric, so that may fail in equivalence relation. Next question they have given same R1 intersection R2. Sorry, okay. Now that is also what? It is reflexive. If you consider R1 intersection R2, it is reflexive. And for symmetric also R1 intersection R2, that means R2 intersection R1 is also true. That means it is symmetric. Next, for transitive, R1 intersection R2 and R2 intersection R3. That means R1 intersection R3. That is common, right? Intersection means what? Common. Common elements. Transitive is also true. So you will say that it is equivalence relation. I hope you are getting the concepts which I am saying. Now the 23rd question. This is one of the most important concepts that come under this composite function. Okay, you say that this composite GOF and you here you write it as FOG. GOF means what? You keep G as it is. What is F? That is function of some X. Okay. Now you keep this G as it is. What is there in F of X? You substitute. That is cos X. And now you should substitute this whole value in the place of G of X. X value. Okay, that will be equal to what? G you keep it as it is, cos X. Now in the place of 3 X place you have to substitute cos X and the whole square. In the X place you have to just substitute cos X. That will give you what? 3 cos X square, or you can take it as cos square X. Here also F and keep G of X, that is function of some X. Keep it as it is. What is here? 3x square. In the place of X you substitute 3x square. Okay, cos 3x square. If you want this variable in beside here, so you bring it out here, cos square X. This will be the answer. They both, oh sorry, this is, see, they have given cos 3x square, right? Cos 3x square, cos 3x square. They both are not equal. You can prove here. Next is GOF. What is G of f of X? I hope you can solve this question. Next is sin X, and in the place of sin square X will be here. For f of G of X will be there. F of, in the place of G of X, what it is there? X square. In the place of sin X square. See, sin square X is different, sin X square is different. Okay, so they both are not equal. The same way you have to show that it is not 1 1, not on 2. Okay, now if you take mod X, it is not 1 to 1 function and it is not on to also. 1 to 1 means if you have two relation, it should be related to only one. If you have here B, C, D, A and all, here A, B, C, D and all, it should be related to only one. On to means, and there comes a concept called surjective and injective. These and all I have explained in the video. You can go and watch through it, full videos. Next is again the same. It is also neither 1 to 1, it is nor onto function. This is the concepts of functions. This is all about the chapter 1 about 3 mark questions. Next I'll be uploading about the 5 mark. For that, make sure to like, share, comment and subscribe. If you're watching the video without subscribing, please watch and while watching you press the button and click the bell icon so that you receive the notification for the next videos which will be I'll uploading. Thank you for watching the full video. Please make sure to like, share, comment and subscribe to my YouTube channel. Stay tuned for the upcoming videos. Thank you. Meet you on the next video.